Welcome. What you are about to watch is not science fiction, and it is not folklore. It is a serious investigation into one of history's most compelling unresolved questions: the mystery of the Phobos Monolith, the object on Mars's moon that looks like a building. Across the world, in universities, research institutes, and field excavations, serious scholars are wrestling with evidence that does not fit the accepted story. Evidence that has been documented, measured, and peer-reviewed, and that still has no satisfying conventional explanation. We are going to look at that evidence carefully, without prejudice in either direction, not dismissing what is extraordinary, but not accepting it without scrutiny either. The truth, as always, is in the details. In 1998, an image came back from the Mars Global Surveyor spacecraft that made people look twice. On the surface of Phobos, the larger of Mars's two small moons, there was an object, tall, rectangular, standing alone on the otherwise barren, cratered surface, casting a long, unmistakable shadow. It looked, in the blunt assessment of multiple observers, like a monolith. 11 years later, Buzz Aldrin, the second human to walk on the moon, brought it to public attention on American television. "There's a monolith there," he said. "A very unusual structure on this little potato-shaped moon. The object, based on its shadow length, is estimated to stand approximately 85 meters tall. On a moon just 27 kilometers across, that is not a small feature." The scientific explanation is straightforward. It is a boulder, ejected from a crater by an ancient impact and now resting upright on the surface. But the explanation raises its own question. Phobos itself is one of the strangest objects in the solar system, slowly spiraling toward Mars, covered in mysterious parallel grooves, with an origin scientists still argue about. Is the monolith just a rock? And what exactly is Phobos? This is where our investigation begins. Stay with us, because the further we go into the evidence, the more extraordinary it becomes. The story you think you know is only the surface. Beneath it lies something far more remarkable. Let us begin. Before we examine the specific evidence, we need to step back and understand the context. This case does not exist in isolation. It sits within the expanding frontier of unexplained cosmic phenomena, and to properly evaluate what we are looking at, we need to understand the broader picture that surrounds it. Space exploration has produced many surprises, but perhaps none as persistent as the anomalies that professional scientists describe and then struggle to explain. These are not the claims of amateur enthusiasts or fringe theorists. They are the published findings of researchers at NASA, the European Space Agency, and major research universities, documented in peer-reviewed journals, and presented at professional conferences, then quietly filed under requires further investigation while the scientific mainstream moves on to the next mission. The anomalies take different forms: unexpected geological features on planet, RE surfaces that do not match known formation processes, electromagnetic signals that arrive from directions where no known source exists, orbital mechanics of small bodies that deviate from the predictions of established gravitational models in ways that suggest an additional, undetected force. Each individual anomaly might be dismissed as an instrument artifact or a modeling error. But when anomalies accumulate across multiple missions, multiple instruments, and multiple research teams, the collective weight becomes harder to discount. Science advances precisely by taking anomalies seriously, by treating the things that do not fit the model as invitations to improve the model rather than as embarrassments to be minimized. The history of physics is largely a history of anomalies: the precession of Mercury that Newtonian gravity could not explain, the cosmic expansion that Einstein refused to accept, the dark matter that bends light with no visible source. Each one, properly investigated, expanded the boundaries of what we understand. This context matters because it tells us something important. What we are about to investigate is not an isolated curiosity. It is part of a pattern that researchers in multiple fields have been independently documenting for decades, and patterns in science demand explanation. With that foundation in place, let us now turn to the specific case at hand. Now we reach the heart of the matter. The core evidence surrounding the Phobos Monolith, the object on Mars's moon that looks like a building, is more extensive, more verified, and more troubling for conventional explanations than most people realize. Let us walk through it systematically, fact by fact, and allow the evidence to speak for itself. We are not going to speculate here. Every point that follows is documented in peer-reviewed publications, official archaeological records, or government archives that are publicly accessible. The question is not whether these facts are real. The question is what they mean. Consider this first extraordinary detail. The Phobos Monolith was first identified in images from NASA Mars Global Surveyor spacecraft in 1998. It appears as a tall, roughly rectangular object on the surface of Phobos, casting a clearly defined shadow. Based on analysis of shadow length relative to the sun's angle at the time of imaging, the object is estimated to be approximately 85 meters in height, a substantial feature on a moon whose longest dimension is only 27 kilometers. This single data point, if taken in isolation, might be set aside. Anomalies happen, instruments malfunction, researchers make mistakes. But as we continue, you will see that this is not an isolated anomaly. It is part of a consistent and documented pattern. But that is only the beginning. Researchers also discovered Phobos is one of Mars's two small moons, measuring approximately 27 times 22 times 18 kilometers and irregularly shaped. It orbits Mars at an altitude of just 6,000 kilometers, closer to its parent planet than any other known moon in the solar system. Phobos completes an orbit in just 6 hours, faster than Mars rotates, meaning it rises in the west and sets in the east as seen from the Martian surface. It bears a large crater called Stickney, 9 kilometers in diameter. Now, a skeptic might propose an alternative explanation for this. And that is entirely reasonable. We should always test alternative explanations before accepting extraordinary ones. The problem is that the alternative explanations, when examined carefully, create more problems than they solve. The mystery deepens when we examine Buzz Aldrin, Apollo 11 astronaut and the second person to walk on the moon, mentioned the Phobos monolith in a 2009 interview on the American network C-SPAN, saying, "There's a monolith there, a very unusual structure on this little potato-shaped moon." Aldrin was advocating for a human mission to Phobos as a stepping stone to Mars, and used the monolith as an example of scientific interest. His comments were widely reported and significantly raised public awareness of the feature. This is where the conventional account begins to strain. Each individual fact might be dismissed or minimized in isolation. But the cumulative weight of the evidence is another matter entirely. Perhaps most remarkable of all, Phobos is slowly spiraling inward toward Mars due to tidal deceleration, losing altitude at a rate of about 1.8 centimeters per year. In approximately 30 to 50 million years, it will either impact Mars's surface or be torn apart by Martian tidal forces as it crosses the Roche limit, potentially creating a ring system around Mars. The Stickney crater, 9 kilometers in diameter, represents a significant fraction of Phobos's total volume. The impact that formed it nearly shattered the moon entirely. Researchers who have examined this evidence have described it as genuinely difficult to explain within the accepted framework. These are not fringe commentators. They are credentialed academics publishing in mainstream journals, raising questions that the field has not yet satisfactorily answered. Then there is the matter of Phobos has a distinctive and poorly understood system of parallel grooves on its surface, running in roughly consistent directions across much of the moon. Several competing explanations have been proposed. Fractures caused by tidal stress as Phobos spirals toward Mars, chains of secondary impact craters from ejecta thrown by the Stickney event, or tracks left by boulders rolling across the surface after the Stickney impact. No single explanation has achieved consensus, and the grooves remain an active planetary science research question. What makes this particularly significant is its independence from the previous points. This is not a case of one theory requiring another. These are separate lines of evidence converging on the same uncomfortable conclusion. Adding to the enigma is this finding: the origin of Phobos itself is debated. Three main hypotheses exist. It is a captured asteroid from the outer asteroid belt. It is material ejected from Mars by a giant impact, or it formed from reaccretion of debris following an earlier disruption. Each hypothesis has difficulties. Captured asteroids typically have different orbital inclinations, and Phobos's spectral composition does not closely match known asteroid types. Japan's MMX mission is designed to return a sample of Phobos to Earth for direct geochemical analysis. Taken together, these facts form a pattern that cannot be explained by coincidence, misidentification, or methodological error. Each piece of evidence has been examined by skeptics. Each has been subjected to alternative explanations, and in each case, the alternative explanation falls short of accounting for everything that has been documented. We are left with a body of evidence that demands explanation and an accepted narrative that does not provide one. This is where serious inquiry begins. Now that we have established the evidence, we need to examine the theories that researchers have proposed to explain the Phobos Monolith, the object on Mars's moon that looks like a building. This is where the debate becomes most intense, because the theories reflect not just different interpretations of the same evidence, but fundamentally different assumptions about what is possible and what the past looked like. Understanding these theories is not just an academic exercise. Each one has been championed by serious researchers with genuine credentials, and each one captures something that the others miss. The truth, if it is ever established, will likely draw on elements of several. The first major explanation proposed by researchers holds that the Phobos monolith is a naturally occurring large boulder, most likely ejected from the Stickney crater by the ancient impact that formed it, and landing in its current upright position. Mainstream plot. Netary science view. The main objection: the feature's apparently rectangular profile and isolated position have led some observers to note that natural boulders rarely present such a regular silhouette, though viewing angle and image resolution significantly affect the apparent shape. This interpretation has significant academic support and is backed by substantial evidence, but it is not without problems. Critics point out that it requires assumptions that go beyond what the evidence strictly supports, and that key predictions of this theory have not been confirmed by subsequent research. It remains contested, and the contest is productive. A rival school of thought argues that the Phobos monolith is an artificial structure left by an ancient civilization, either built on Phobos or placed there, promoted in alternative science communities. No scientific support. The main objection: ESA's Mars Express spacecraft imaged Phobos at high resolution from multiple angles, and the object is consistent in all respects with a large, naturally occurring boulder. No other features on Phobos suggest artificial construction of any kind. This theory is controversial, and deliberately so. Its proponents argue that the evidence demands an explanation outside the conventional framework. Critics counter that extraordinary claims require extraordinary evidence, and that the evidence presented, while suggestive, does not yet meet that standard. The debate continues in peer-reviewed literature. Perhaps the most unconventional theory suggests that Phobos itself is an artificial satellite, a hollow structure of alien origin, and the monolith is part of this body, proposed by Soviet astrophysicist Iosif S.H. Shklovsky in 1958. Based on anomalous orbital decay data. The main objection: S.H. Shklovsky's calculations were based on incorrect data. When orbital decay was properly measured, it matched natural tidal deceleration exactly. S.H. Shklovsky himself later withdrew the hollow Phobos hypothesis. What is striking about this debate is not merely that experts disagree. That is normal and healthy in science. What is striking is the quality of the disagreement. Serious researchers working from the same body of evidence, reaching genuinely different conclusions. That level of fundamental disagreement, when it persists over decades, is a signal that something important has not yet been understood. The question is not which of these theories is right. The question is whether any of them is right, or whether the truth is something that none of the current frameworks has yet been able to capture. The case surrounding the Phobos Monolith, the object on Mars's moon that looks like a building, does not rest on speculation alone. What distinguishes this investigation from pure mythology is the existence of documented, physical, verifiable evidence, material that has been examined by credentialed researchers and whose authenticity is not seriously disputed. What is disputed is its interpretation. Let us review the most significant documented evidence as objectively as possible. We are not going to cherry-pick the data that supports a preferred conclusion. We are going to lay out what exists and let you draw your own assessment. Physical evidence supporting this account includes ESA's Mars Express spacecraft has made multiple close flybys of Phobos since 2003, including approaches within 67 kilometers of the surface, imaging it at significantly higher resolution than the original Mars Global Surveyor images. These images confirm that the Phobos monolith is a large boulder consistent with the type of rocky fragment ejected by major impacts on airless bodies. The rectangular appearance is attributable to viewing geometry and the natural fracture planes of rocky material. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Investigators have documented the 1958 S.H. Shklovsky hollow Phobos hypothesis was based on orbital decay measurements suggesting the moon was decelerating faster than gravitational and solar radiation pressure alone could explain, which S.H. Shklovsky argued implied a hollow body with very low density. Subsequent precise measurements of Phobos's orbital decay showed it matched natural tidal deceleration predictions exactly. Phobos's measured bulk density is 1,876 kg/m3, low but consistent with a porous rocky body, not a hollow shell. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. On-site analysis revealed Japan's MMX, Martian Moon E-exploration mission, scheduled for launch in 2026, will orbit both Martian moons and land on Phobos to collect a surface sample for return to Earth. This will provide the first direct geochemical analysis of Phobos material, expected to resolve the origin debate. Direct sample analysis will definitively establish whether Phobos material matches known asteroid or Martian impact ejector compositions, and the monolith region will be imaged at the highest resolution yet. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Each individual piece of evidence might, in principle, be explained away. A single anomalous artifact might be misidentified. A single anomalous date might reflect contamination. A single anomalous eyewitness account might reflect misperception. The question is whether all of the evidence can be explained away, and whether the explanations required are more or less plausible than the evidence itself. When multiple independent lines of inquiry converge on the same conclusion, that convergence is the most powerful signal in empirical science. And that is exactly what we are seeing here. We have examined the history, the evidence, and the theories surrounding the Phobos monolith, the object on Mars's moon that looks like a building. Now, we need to ask the question that is sometimes overlooked in discussions of ancient mysteries. Why does this matter? What does it mean for us today? It would be easy to file this away as an interesting historical curiosity, a puzzle from a distant past with no bearing on our present lives. That would be a fundamental mistake. The questions raised by this case touch on issues that are directly relevant to who we are, where we came from, and what the human story actually looks like before the period covered by conventional history. The Phobos monolith's nature as a large boulder is confirmed by ESA Mars Express imaging. Phobos itself remains one of the more scientifically interesting objects in the inner solar system. Its origin, its grooves, and its inevitable fate are all active research questions. Japan's MMX mission, targeted for a 2026 launch with a sample return around 2031, will provide the most detailed data yet on the Moon's composition and geology. Whatever Phobos is, captured asteroid, impact remnant, or reaccreted debris, it will eventually either rain down on Mars or break apart into a ring. The monolith, boulder or otherwise, will go with it. Furthermore, the tools available to investigate these questions are advancing rapidly. Satellite imaging, ground-penetrating radar, ancient DNA analysis, isotopic tracing, and deep-sea sonar are all providing capabilities that previous generations of researchers could only dream of. Cases that were genuinely unresolvable 10 years ago are now open to new analysis. And the findings, consistently, are expanding rather than contracting the mystery. The investigation continues. New discoveries are being made. New analyses are being published. New voices are entering the conversation from disciplines that were not previously part of the discussion. The answers, when they come, and they will come, will not merely solve a historical puzzle. They will force a fundamental revision of assumptions that underpin our entire understanding of human history and human potential. We have now walked through the complete case of the Phobos Monolith, the object on Mars's moon that looks like a building, from the historical record, through the physical evidence, across the competing theories, and into the modern significance of what remains unresolved. What the story of Phobos Monolith ultimately reveals is not just a historical puzzle. It is a mirror. It reflects our assumptions back at us, our assumptions about what ancient people were capable of, about how knowledge is gained and lost across the centuries, and about the relationship between what we know and what we merely think we know. The evidence presented in this documentary is real. The questions it raises are genuine. The debate among researchers is ongoing, and that is healthy. Science is not a set of conclusions. It is a process. And the process requires that we remain open to evidence that challenges what we thought we knew, however uncomfortable that challenge might be. If you came to this documentary as a skeptic, we hope the evidence gave you something to think about. If you came as a true believer, we hope the critical examination gave you a more nuanced picture. The truth, as always, lies in the evidence, not in what we want to be true. Thank you for watching. If this investigation sparked your curiosity, please subscribe to the channel. We publish new documentaries every week, covering the full range of historical mysteries that the mainstream has not yet adequately explained. Leave a comment below telling us which case you want us to investigate next. The conversation continues. The investigation never ends.